Okay, so for 52 we have to simplify and write the answer in standard form. So first off, this one right here would be 6i, because the square root of negative 1 is I, and the square root of 36 is 6. So this would be 6i right here. So it becomes negative 6 minus 6i plus 7i minus 3. So the real part would be these two, and the imaginary part would be these two. So negative 6 minus 3 is negative 9, and negative 6i plus 7i is positive I. And that's it. Alright, so 53 does not factor by grouping. I didn't show it here on the screen, but you could try it on your own and you'll see it doesn't work. So we have to use the P over Q method. So for 68 we have plus minus, factors of 68 are plus minus 1, plus minus 2, 4, plus minus 4, 6, 7, so I think it's 4 goes into this 17 times, so plus minus 17, plus minus 34, and plus minus 68. So these are the factors of 68. 1, 2, 4, 17, 34, and 68. So we'll start with positive 1. And again, because it has a negative in front of the 8, then we could use positives, because we could potentially have a 0 if I use positives. So I'll start off with 1. 1 minus 8, 14, 68. Okay, bring down the 1, negative 7, and it's too small, right? Because I'm going to get a 7 here, and it's going to be, I need actually a negative 68, so this is not going to work. I'll try negative 1. Bring down the 1, negative 9, 9. Again, it's not going to work because I need a negative 68. Or I need a 68 here, so it becomes negative 68 down here, so that's not going to work. I'll try 2. So that gives me 1, negative 8. Bring down the 1, 2, negative 6, negative 12. It's not going to work. I'll try negative 2. Down 1, negative 2, negative 10. What is it? 20, 34, negative 68, and that one worked. The negative 2 worked. So remember, the 1, negative 10, 34 is x squared minus 10x plus 34. Okay, so you're looking for factors of 34 that add up to negative 10, and those don't exist. So when that happens, you have to use not completing square, you have to use a quadratic formula. So I'll move this up a little bit so we can do that work here. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that gives you 10 plus or minus 100 minus, what is it, 68, 136 all over 2. So that's going to give you 10 plus or minus negative 36 all over 2. That's going to give you 10 plus or minus 6i all over 2. I can reduce everything by 2 by factoring out a 2. 3i all over 2, so then I can cancel this way. So the zeros are, don't forget about the one we got with synthetic division. negative 2, and then 5 plus or minus 3i. So that's a total of 3 zeros. Alright, so for 54, it's asking for the domain. We look at the denominator, and it doesn't factor. No factors of 21 add up to negative 4. So when you look at the discriminant, the b squared minus 4ac, that goes inside the radical of the quadratic formula, I get 4 times 4, negative 4 times negative 4, 16, minus 4 times a times c. Without even doing the math, the computation, you already know that this is going to be bigger than this one, right? So it's a negative inside the radical, so it has no real solution. So the domain is all reals, because nothing makes it 0 in the denominator. Then it's asking you to see if it has any wholes. Well, since nothing cancels in the numerator and denominator, there are no wholes. Okay? Then it asks you for vertical asymptote. This is a powers equal rational function. So then that means that you look at the, for vertical, since the domain was all reals, it has no vertical asymptote. For horizontal, on the other hand, because its powers equal, it's y equals the coefficients of the numerator over the denominator. So y equals 3. And that's what it asks for. So it's asking for domain. So let's factor the denominator. We get x plus 8 times x minus 8. So then you get domain all x such that x cannot equal plus or minus 8, because that would make the denominator 0. Then it asks for any wholes. Well, since x plus 8 and x plus 8 is a common factor, there is a whole at negative 8. So let me put this here. So let's cancel this out right here. That's because it's 1, you're left with 1 over x minus 8, right? So the whole would be at negative 8, and to get the value of the y, you put a negative 8 right there. So it'd be at 1 over negative 16. So that's where the whole would be. Vertical asymptotes, the only thing that's left in the denominator that would make it a 0 here is 8. So vertical asymptote at x equals 8. Okay? And this is a bottom heavy, so it's automatic horizontal asymptote at y equals 0. Alright, so domain is whatever makes the denominator 0, so that would be negative 3. So you say all x such that x cannot be negative 3. Okay, wholes, well, if there's any common factor, and we do have common factor right here, so that's gone, and so that would give you negative 3 for the x coordinate. So that means you're left with x minus 3, right? So you would put a negative 3 there, and so that gives you negative 6. Okay, the vertical asymptote, because the negative 3 was the only thing that was in the domain, and it became a whole, then there is none. No vertical asymptote. And this is a top heavy, so this would be an oblique or slant asymptote. So you'd have to do the long division. X plus 3 into x squared plus 0x minus 9. We have to put a placeholder. So x goes into x squared, x times x plus 3. We're subtracting, x squared. We're subtracting, I forgot the x on both of them. I'm subtracting, so that's minus, and then this turns minus. So you're left with negative 3x minus 9. So then the next one would be negative 3. And when you subtract, you add the opposite, so you get 0. So this would be your slant asymptote. Y equals x minus 3. Okay, so number 57, factors like I have here on the right side. You can use x factor or the box method, whichever you prefer to factor. and this is what you get. Domain, the only thing that makes the denominator 0 is 9. So we say x such that x cannot be 9. Okay, since no factors cancel, what was I writing here? It should be whole or wholes. It has none. Okay, vertical asymptote would be anything that makes the denominator 0 that's not a whole, so it'd be 9. X equals 9. And then because this is top heavy, we have to do long division to see if what the slant asymptote is going to be. So x minus 9 into x squared plus 37x minus 72. Okay, so x times what gives you 5x squared? That would be 5x minus 45x. So when we subtract, we add the opposite. So that's minus and that's a plus. So that gives me 0 here. And what is it, 70, 82? Okay. And so x times something gives me 82x, so it'd be plus 82. So that's 82x. And I could do the multiplication and stuff and get the answer here, but it wouldn't matter because this is going to be a remainder. So I don't care about the remainder, I only care about the quotient up here. So the slant asymptote is going to be y equals 5x plus 82. Alright, so here's the function for number 58 in factored form. For the domain, remember, we always, before we cancel anything, we always look at the denominator and see what makes it 0. In this case, it's 2 and 4. So it's x such that x cannot equal 2 or 4. Okay, everything else is okay.